Hello again to another INB382 demonstration video, and I have here the Cube Map demo. So as we can see here, we don't even have to run it, but if we can just see in the game, we have this sphere which has been cube mapped with, I believe, the contents of the Sistine Chapel from an environment map, cube map that I found on the web, which we'll also see a reference to in the shader. So as you can see, I actually quite like running these sort of shaders because you get this really impressive looking object that appears to be reflecting an environment around it. So this is, I guess, we'll call it a cheap form of reflection, or just a quick basic form of reflection that is not global in nature. It doesn't account for other objects nearby. So if I was to replicate this sphere, you'll note that you won't see the reflections of the sphere from each other because it's just sampling from a cube map. So it's a nice first one reflection bounce effect. Okay, getting past the admiration of its appearance, let's go down to how we actually create some of the resources. So again, the resources, there is a cube map resource type in Unity. If you go right click and you'll see, actually if I can get that into the window, you should see in the corner here, cube map. So this means that if you want to create a new cube map as a resource and then load it up with images, you go via here. So I did that and created my cube map. That's all Jim Dandy. And we look here in the inspector and the 6 faces. Remember, the cube map is made up of 6 faces pointing in each of the positive and negative directions of each dimension, X, Y, Z. You need to load them up with images. So here we have some images from Sistine Chapel, which have been provided by someone for free on the net. And what you need to then do is effectively load these resources up as well, set them all up with appropriate sampling, as I've shown in the other videos. Again, you can see the maps here as the subsamples. So they're all just straightforward textures and texture resources. And then what happens is, okay, when I get to build my cube map, when it sits in the resources, so this is actually created on disk, it's a structure, it sits on disk. You can select from the available textures inside the project. So I've got bits and pieces there. So if I want to, I can change that one to this sort of blurry dot, default particle effect texture. And as you can see in the, actually I might do that again because I'm doing it off screen. So let's bring it here. So because, of course, just to be tricky, that even though it looks like it's the negative side, it's actually positive X. So what we want to do is fill it with negative X. Yep, even though it's matching positive X. Have a look in the lecture notes just to note that these things have been switched around because I think the guy who created the environment maps used a different coordinate system in the assumptions when he made the names of his textures for the environment map. I digress. So again, we can select for the positive, suppose we can just replace it with these other textures, and you can see it just immediately loads it up, and the shader accesses it from the cube map, and it's all able to provide the environment map effect. So we can see here it's incorrect, but it gives you insight into the fact that you need to set these up so that you get the correct images installed for those locations so that you get finally the right appearance of your cube map. So that's how you create a cube map in Unity. It's fairly straightforward. You can do it from here. You don't have to do it in a script. You can do it in a script. It's just logical. Create the resource, but then I want you to load it up from the script because I think that's just good programming sense. Going back up, so there's the shader, the material, and as I've created a new material for cube map and added a shader to it and so forth. There's the resources. So if we move to the scripts and the shaders, it's fairly straightforward to use such cube maps. So as you can see here, just noting that these environment maps are from Emil Pessin. aka hummus. So there's a nice resource there if you want to just play around with some of the environment maps. There's plenty of environment maps on the web. I'll leave you to find them as cube maps. Now, looking down the bottom here, we see that we have a cube map type in the scripting, and we see here that it's a texture, and we can load it by just using the resources.load function, and we are going to, of course, load it from the mycube map that we created over here. So it's just going to look in the resources directory and find my cube map. I've already created it. And then, okay, type of cube map. No, it's pretty straightforward. You get a cube map as a texture. Then, again, you set that as a uniform variable in your cube map shader. So we pass it in. Again, there's a variable, a uniform variable called _cube map there. And we pass it in as a texture using the render.material set texture. So it's just a specific type of texture. And in the end, it's using the same sort of similar ideas about texture coordinates. The only thing to note is that it uses a vector as its input. So instead of just being a 2D coordinate, it's actually a 3D coordinate or a vector. Anyway, moving right along, here's our property section, cube map. Note it uses the keyword cube. I made it red for some reason by default. Do whatever you want. And in the CG code, we have the sampler cube type for the uniform variable. So following along from the theory in the lecture, so the vertex shaders and the pixel shaders implement that theory that I've shown you. So again, the positions are projected and transformed for the camera, and they're world transformed, all by the usual Unity matrix MVP. We will need, though, the position of the vertices in world coordinates. So we transform them to world space. So we just use, okay, a subset about this one here, the object to world matrix, which is provided by Unity. It's a keyword. Not a keyword, sorry, it's actually provided variable by the Shader Lab system. And that position in world space is then used concurrently with another variable that Unity lovingly provides, which is the camera position in world space. So you're given that, and it makes it a lot easier for you to keep track of these things. You get the I vector, or the 2 vertex vector from the theory. So this is what we're going to use to figure out which cube map is going to be selected. And that's all hidden from you. I show you the theory. That's all hidden from you, but you need that I vertex. Then you have to do the typical transpose world to object transform on the normals so that they are undistorted when we do our calculations. So we're calculating their transforms into world space. Effectively, we just do rotates and so forth. No projections are done, so it means that the normals are not distorted. Blah, 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 blah. So our output structure is going to contain, an I vector, the normal, and the final projected position. So when we get to the pixel shader down here, we need to generate the environment vector. So we've got the I vector, 2 vertex, and then we need to reflect that around the normal, the transform normal in world coordinates. And lo and behold, there's a reflect function. Okay, so we've got a macro, it's already been set up in CG that does this for you. Give it the I vector, give it the normal, you get the environment map vector. That's a reflection around the normal. That's the vector you use to sample the cube map. Then, the color you return on the surface of the object that this shader is running on ends up being just this call here. So there is a texture cube call, not tech2D, this is texture cube. So it knows it's a cube map, and it implements that theory that I show you in the lecture about selecting the faces of the cube map. And of course you just use the variable, and you pass it the environment map vector so it selects the correct face at that position on the surface of the sphere to make the reflection effect occur. And lo and behold, once that's executed, you get this appearance here. So this is a quite effective little reflection effect, and you're able to add this, and again, as I've shown in the other videos that there is indeed ability to blend these textures with other textures. So the nice idea with this is you can blend this environment map texture with another texture to create something that looks semi-reflective. So keep that in mind for your objects in your games or whatever. And this, you can blend all this together either using multi-pass or multi-texturing. Have a look at the demos to create some nice effects. Or you can turn off the reflections. So you can use one texture to turn one on or off. So that means that some armor could be in places covered with rust or covered with this reflective surface, so you get a nice effect. So keeping that in mind, this is therefore a very useful shader to use in your games for such effects, and it's nice and cheaply computed. So that brings me to the end of this video. Thank you very much.